Okay, U1L2. So we talked about math models already, but I still want to go through and fill out this slide. You should already have done that on your lab, but just so we have the slide to reference whenever we're talking about math models. So math models need to be straight line only. For right now, most of our labs are going to naturally be straight lines, which again is y equals mx plus b, right? Later, we'll talk about how if it's not a straight line, what do we do? Because with curved lines, we need calculus typically. And again, we don't know that. The key thing is that when you write your math model, you're replacing y and x with your experiment variables. So again, from our lab we just did, our y was actually x for position. I know that's confusing, right? And our x was t, because this was an x versus t graph, position versus time. And we're actually going to be talking about that today as x versus t graphs, position versus time graphs. So there's two types of math models that, again, I only made you do one kind for this first one. But if we say specific math model, this means specific to your lab. And that's actually what we did in the lab. It comes from the graph using the collected data. And then usually we want to include the units. I kind of skipped that step. But again, it comes from the graph using the collected data. So we had our actual numbers. Again, for example, I had x equals 1.14 t plus my 5.1, I think, something like that. So this was my specific math model because it came from my data. The general math model, though, we talked about it, uses variables only. And what that does is it replaces the numbers with the things they represent. We talked about how the 1.14, think for a second about what that represented. What did our slope represent for that graph? Well, it represented velocity, right? So I would replace that with the variable for velocity, which is v. Give me 1 second. So I have x equals vt. Now, we're going to learn this actually a little bit later, but this was our starting position. We can call this our x initial. We're going to learn that later. So like this would be my general math model for any buggy, right? My position equals my velocity times my time plus my initial starting position. So again, this was my specific math model, specific to my graph. This is my general math model. And again, it replaces the numbers from your specific math model with their corresponding variables. So I just wanted to clarify that one more time. We'll reference this later as we get into more labs. Okay, we're only going to do one little thing here. We're going to do one slide, and then we're going to come back and continue tomorrow. So position versus times graphs. So we've already looked at motion maps, which again are just those dots, right? We have an example of motion maps here. XT graphs plot time and position on the XY axis, right? The actual so we can take a motion graph and we can make it into a normal Cartesian XY graph. So what we do is we're going to look at, we have our starting position here and our final position here. Again, x initial, x final, we call that. So we know that, again, time is going to be on the x-axis, so we'll go ahead and label that time in seconds. And position is going to be on the y-axis, and that's in meters, right? Again, this is x and this is t, right? Those are our variables for each of these quantities. So what I'm going to do is I'm going to look at each dot, because each dot represents a time and a position, yeah? And I'm going to create my graph based off of that. Now, for the most part, because these are straight lines, we can, and also because they don't tell us the exact position. See how that doesn't tell us? It tells us every 5 seconds where I'm at, but not the exact position. We're going to go ahead and just plot the first point and the last point and connect the dots. So our first point is at t equals 0. I'm at -10. So I want you to put that on this graph. Where would that go? This is t equals 0. My position is -10. Where would that go? Well, -10 is going to be down below the x-axis. They're telling me that I am starting behind whatever I have chosen to be 0. I've chosen a certain point to be 0, and I'm starting behind that point. So that's our starting position right there. Then I need to go up to, at 25 seconds, we got up to 40. So what I want you to do from here is finish marking off your y-axis in uniform units. Yes, we started at t equals 10 seconds. We went up to, We started at 0, then we're going up to 5, 10, 15, 20, right? So be careful here. And again, we're going from -10 to 40. So finish marking off this axis here, and then we'll go from there. Okay, so I have -10. Now I'm going from -10 to 40, so I'm going to go ahead and go up by 10. You have to go up in the same quantity of units. So if I'm going to -10, I'm going to go ahead and go up to 0 from here. Duh. I'll go up to +10, +20, +30, and I'm ending at +40. And then again, I'm going to go ahead and mark off my times at the bottom. I had t equals 0 originally. I have t is 5, 10, 15, 20, and 25. Now again, we don't know the actual positions for these, but our graph could actually help us figure that out. I'm just going to go ahead and plot this point here and then connect the dots. So go ahead if you haven't already done so. At t is 25, I'm at position 40. Where would that dot go? Time 25, position 40, and then draw as best of a straight line as you can. There's our graph. Now, one little point I want to make here. When we are doing a graph with data, you cannot do not continue the line past data that you don't have. Do not continue the line. End it where it ends, right? Again, we don't know. We don't have data for anything else. So even though the graph can give us an idea of what's further ahead on the AP test, when you are graphing data, you go, this is what we have. We know nothing else. We don't want to show anything else. So don't continue the line. Don't put an arrow here. Just put a dot. Yeah. Okay, so this is our motion graph. We're going to talk about what the slope of the line, what does it represent, what does the sign tell us. We're going to talk about that more in class. But this is just a general position versus time graph. You guys did this in your lab. It tells you where you are at any time.